Okay, in this video we're going to talk about working with matrices in C#, and in particular we're going to talk about one of my absolute favorite math-related libraries, which is freely available, and that is MathNet. And MathNet has a lot of linear algebra functionality to allow you to work on matrices and vectors, and we'll talk about some of that and get you familiar with what it does. Now, the first question you might have, coming from a C# background, is I know what arrays are in C#. I've probably worked with them a lot. Well, what is a matrix? Well, if you recall from your algebra classes in school, you've probably seen equations like this, where I've got two equations and two unknowns, and the unknowns are x and y, and you have to figure out what x and y are from these two equations. Well, that's okay for humans to work through an equation like that, but for computers it's a little bit more difficult. So there is another way to represent these two equations that is a lot easier for computers to work with, and that is by using matrices and vectors. And here on the right I have a representation of these two equations that is exactly the same as these two equations, but in a different format. And it's in a format that computers can work with a lot easier. And you can see I've got a matrix multiplied times a vector equals a vector. And the approach here is to take this vector, multiply times the matrix, and you will get these two equations. So the way you do that is you take this vector, flip it horizontally, and multiply the vector times the matrix. You start with this row and multiply x times 4 plus y times 3 equals 12. And you can see that's exactly that first equation, 4x plus 3y equals 12. Then you take the vector, move down to the next row, 1x minus 8y equals 3. Exactly the same equation. So you can see this is just a different way of solving what are linear, these are linear equations, doing algebra on linear equations. So that's all we're talking about here, and it's a very, very powerful and useful way to solve linear problems, and it's used in just about every industry, and it's very important for you to be familiar with. So to do this, we're going to use what I said is called MathNet Libraries, and again, they're freely available. And we'll start up and do a simple Windows Forms application, but just to tell you what we're going to install, there's two libraries in MathNet, the numerics and numerics.data.text, and we're going to have to add some using statements to our application. And the main support website for this library is numerics.math.net.com, and I'll show you, here's that website. And in the matrices and vectors section, it's got some basic information about how it's set up. Not a whole lot of information. You still might be a little bit overwhelmed. The most important part of this, in my view, is the class reference section. And there are many, many classes with methods in this MathNet Numerics library. And this class reference section describes all of the methods and classes that are available to help you do your thing. So you can see here's the list of all the namespaces available. What we're going to do is we're going to first look at the linear algebra, which works on matrices and vectors. And we're going to start with the complex 32 libraries. And if you recall from your algebra, complex is basically just complex numbers that have a real and imaginary part. And complex 32 means they're 32-bit numbers, floating point numbers. So we're going to do complex because if you understand the complex, then it's easy to do the simple double or the single format numbers. So we'll start with complex 32 and click on that. And we will go to the dense matrix. And there's dense matrix, there's sparse matrix. I won't go into depth about the difference, but basically a dense matrix means it's a matrix where most or all of the elements are non-zero. So we're going to start with that. So we've got the dense matrix, and here are all the constructors, static functions, methods, and properties that are available to you for this complex 32 dense matrix class. And you can see it is overwhelming. There are just tons and tons of methods that you can use to work with your matrices. So yeah, it can be very overwhelming at first, but we're going to show you a way to work with these that hopefully will remove a lot of the confusion. If you scroll down here, there's just pages and pages of descriptions of each of the methods. And it can be, some of these really don't have a lot of information, and it can leave you scratching your head about what actually it does. But I want to give you a little background in what each of these references, method references, means. So really, each of these items is basically a standard method descriptor, where you've got a method name, just like in C#, you've got a method name, and this one's called column, and it's got the input parameters in parentheses, and this has got 3 input parameters, and a return value, which here in this case is a vector. So each of these is basically just describing the method and the input parameters and the return value. So you can see it's got a list of the parameters and the return value and a little description. Again, this may not be enough to help you know exactly what it does, but we're going to show you a way to help you with that. So once you've got that, keep in mind that if you're going to work with complex numbers, it uses floating point numbers for the real and imaginary values. So make sure, because in some cases you're going to have to specify that the numbers you're working with are floating point. So just that's to keep in mind. Now, getting started. First of all, the first question you may be asking, how do I find matrices to work on? Now, in the real world, you're probably going to need to import some files, some matrices. Maybe somebody's got some data that you need to work on. You're going to have to import a file. So one method we're going to look at is using CSV files, and that is a comma separated value file, which is basically a text file that has individual values for each value in the array separated by commas. Now I've got another video talking about CSV files in general with C#, but MathNet has some wonderful methods that allow you to directly read in a CSV file that has each of the array elements separated by commas, and it automatically populates an array for you and parses that file and puts it into an array. So it's really a wonderful method to help you just read in a file directly. And you can generate that file yourself. You can use Notepad. You can also do an Excel spreadsheet, save it as a CSV file or as a text file with comma separated values and read it in. And what we're going to do is we're going to do both of those with Notepad and also with Excel, and show you how to generate a CSV or a text file and read it into MathNet. Now, one caution: when you're making these files, make sure there are no spaces between the values, okay, or else you might get an error. Now, there's ways around that, but to simplify this, we're going to generate some files, and we got to make sure there's no spaces, or else it won't like the input. So the first thing we're going to do is we're going to look at making an array in Excel and also in Notepad. So here I've got Excel and I've got Notepad. So let's start by making a simple 2x2 array, and we're going to make complex numbers, and we'll just type it in. And to do a complex number, you have to do a parenthesis, and we'll say 2, 3, that's the first element, and 4, 5 is the next element. And see, I forgot my parentheses. 4, 5, and then the next row of the array will say minus 4.5, 3, parentheses 86.576, 1. And that is going to be our array, and it's got 4 complex values, okay? So we will save that. Save as, let's call it csv.text, and I'm replacing what I got. And now we will do the same thing in Microsoft Excel and save it out as a different file, and then go in and make a Windows Forms application to read those in. So here I'll do 2, 3, 4, 5, 6, 7, 18, 20, and we'll save this file, save as, and we can save it as a CSV file. And you go down here, CSV, and we will call it Excel CSV and save it in the same location. I'll just say yes. So now we've got the two files saved, and what we'll do is we will go into Visual Studio and we will generate a Windows Forms application and see if we can import these into the Windows Forms application. So here's we start out with a simple Windows Forms application, and what I'm going to do is I'm going to add a simple button and a text box, and that's it. Text box right here. Now the first thing you got to do with the text box, make it a multi-line. Click on that little arrow, make it multi-line, and then draw it out. So now you've got your text box, and in this text box we are going to print out our input and output matrices. So first what I want to do is button 1, let's make this text a little bit, this font a little bit bigger, and we'll call it 12, and this will, the text of this will be display. So now we've got that, and this text box we will leave it as text box 1, and now we're all ready to write our code to read in these files. So we'll double click on this, and we said the first thing we need to do is we need to get the MathNet libraries and download them from NuGet. So we go to Tools, NuGet Package Manager, Manage NuGet Packages for Solution, and we will go to Browse, and we will search for MathNet, and here you will see MathNet.Numerics. We need to select this and install and say OK and wait for it to be done. Now that's done. Now the next thing we need to do is MathNet Numerics Data.Text, and that will help us to print out our matrices to our text box. So we install that, say OK, and now we've got the two packages installed and we're all set to go. So now we just do a using statement here, using MathNet.Numerics, and then using MathNet.Numerics linear algebra for our matrix operations, and using MathNet.Numerics.Data.Text, and that will help us print out to the text box. So we've got that. Now the first thing we want to do is put in some code that will allow us to read in those text files. So what I'm going to do is I'm just going to copy and paste 2 lines of code to show you how simple it is to do that. Now I'll uncomment these, and here I've got one line of code that will allow me to read in each text file, and here is the only line of code I need to print that matrix that we generate from that text file out to the text box. Okay, so to read it in, I basically define a matrix, and this is going to be a complex 32 matrix, and we're going to call it file matrix. That's our name for it, and we're going to use the delimiter delimited reader, which is a reader method in the MathNet Numerics that allows you to read a file and put it into this matrix. Okay, it automatically does the parsing. So the delimited reader class read method, and it's going to be complex 32, and here is just the parameters we need for that. And if you do IntelliSense over the read, it says we need a file path, then a Boolean, whether it's a sparse matrix, and that's going to be false. A delimiter, string delimiter, which is going to be a comma since this is a CSV file, and then a Boolean if it has headers. And we talked about that. These files don't have headers. So basically, I put in the path to the CSV file that we just generated, a false saying that it is not a sparse matrix, it's a dense matrix, and then the delimiter, which is a comma delimiter, and then false, which just says it doesn't have a header. So that's all you need to read it in and put that data into this complex 32 file matrix. And then to print it out, there is a wonderful method that each matrix has, and it's called toString. And that automatically formats the matrix so you can print it out as a string to a text box. Now, it normally doesn't have any values, but you can place a value in the parentheses. This is a method, and you can tell it to use this F2, for example. If I want a fixed with 2 decimal places, I can put in a format like this, and it will obey that formatting. So now I've got basically all I need to read the file in and print it out. So I will start the application and display, and you can see I've got my matrix. I'm going to go through, and it's kind of small. I'm going to go through and fix that. So now I'm going to go to this text box and change the font to, let's say, 14. And now I've got bigger font. I'll run it again and display, and there you go. That's the matrix that I read in from the CSV file that we generated in Notepad. Okay, so one other thing I want to do is I want to add a button to exit. So we will say exit, and we will do application.exit. Okay, so now we have basically all we need to read in a CSV file. Now I'll also show you how we can read in the Excel CSV that we made. And we'll change this to, it's a CSV file that we saved out of Excel, so CSV. And then I will run it, display, and there you go. That's the one we saved out of Excel. So basically, you can convert it in Excel, or you can do it on your own using a notepad or whatever you want. So it's very simple to read in and display. So I strongly recommend that you use this simple toString and you set up a Windows Forms application. So if you want to use some of the methods, and we'll go through some of these methods that are available for the file manipulation, or the matrix manipulation, and you can see exactly what the input is and what the output is. Now I also want to mention you can also generate arrays that follow, for example, a sinusoidal wave or a sawtooth wave or square wave. There's a generate method in MathNet Numerics that will generate an array that follows a sinusoidal wave or a sawtooth or square wave. I won't go into detail how to do it. It's fairly straightforward, just a method, and you put in the parameters and it generates an array, and you can use whatever you want with it. So now we've got the importing covered, we can talk about generating your own matrix in your code. And there's a few ways to do that. The simplest way is to just specify that you generate an array and you fill it with zeros. And here is some code that all you need to build an array This is the code you need to build an array and output it to the text box. And so here's all we need to generate an array, a matrix X, which is a complex 32 matrix, and it's a 4 by 4. And we are just instantiating this matrix using the build dense method. And we're specifying it's going to be a 4 by 4. And it will then, like I said before, it'll take this matrix, use the toString method, and we'll send it to our text box. So we start up display, and there you go. You've got a 4 by 4 matrix populated with zeros, complex numbers. And MathNet also gives you a header explaining what it is, and it puts it in the right format. We gave it the F2 for 2 points, floating point numbers, so it's nice and clean and very easy to work with. So there's another way to do it, and that is you can specify, you can give a function to specify each element in the array. And here is an example of how we would do that. I've got, and I'll comment out this last one. This is a modified version of this, this first build dense, and it does the same thing. It builds a 4 by 4, but in this case we are specifying that the ith and jth element, for each element, I and j, we do this. And this arrow says do this. And it instantiates a new complex number of 1. And we're specifying a floating point. Remember I said it has to be floating point. For a real value of 1 floating point and an imaginary value of 1 floating point. Okay, so I am populating every element in the 4 by 4 array, each I and j element, with a new complex 32 value of 1 plus I1. And then I am outputting that using the matrix toString, and I'm sending it to the text box. So let's start that up. And you can see I've got 4 by 4 complex numbers. Each of them is 1. Okay, so you can see it's very easy to figure out what each method is doing, because you just change the number and output it to the text box. Now the next thing we can do is we can multiply the matrix we just made by a number. And to do that, there is a method called multiply. So I will just copy and paste that and uncomment. And here we have y.multiply. And all this does is it says, take every element in y and multiply it by what's in this parentheses. And it basically uses this number, this new complex 32 number, which is a value of 2 for the real and 0 for the imaginary, which means it's basically multiplying y, every element, by 2. And it's putting the output into this n matrix. So what I'm going to do is I'm going to rename this X matrix as n, and I'm going to send the result to this n. I'm going to send the result to n out to the text box. So we've got y, which is going to be all 1s. We're going to multiply all of those by 2 and output the result. So we'll do start, display. So here's the input. I multiply them by this real value of 2, and now I've got 2. So you can see, pretty straightforward and nice and easy way to figure out what does this multiply do. It actually multiplies each element and shows you how you can do it with complex and everything else. Now there are some other methods that extract portions of your matrix, and you can send them out to the text box. So you can extract a column, you can extract a row, and in this case I'm going to use the matrix.column method and extract a portion of the matrix. So let's extract the Y matrix, column 2. Let's make it column 1. and send that out, and that's going to be basically a vector sent out to the text box. So we'll start display, and there you go. It took one column out of that matrix, this first matrix, and it gave you the values as a vector. Another method that they have in the MathNet Linear Algebra is you can sum each of the columns or rows in a matrix. And I'll use the column summing method. And basically, you can see I am taking the sum of all the columns in this Y matrix that we made before. And you recall it's basically I filled in ones, complex 32 ones in each of the four array elements. And I'm summing each of those and putting them into a vector. So there should be 4 values in the vector, and I'm outputting that to the text box. So I'll run that, and you can see the original array had 4 by 4 with complex 1, 1 in each, and the sum of each column is 4 and 4 for column 1, which is right here, 4 and 4 for the next column, which is right here, and so on. So you can see exactly what that method does. Now there's one important thing I want to mention about the assignment operator, basically the equal sign. And it may operate a little bit different than what you might expect. So what I'm going to do is I'm going to have 2 matrices here. I'll start out with my X, which is basically a 4 by 4 with zeros, and a Y, which is a 4 by 4 with 1, 1. And what I'm going to do is I'm going to set X equals Y. And here is the code for X equals Y. So I'm basically saying that X equals Y, and as we call Y is all ones, X is all zeros, so X will now become all ones like Y, right? Then what I'm going to do is I'm going to take X and multiply each value, like we did before, times the real value of 10, and put that back into X. So I'm going to overwrite X. Instead of ones, it's going to be all tens. And what we're going to do is we're going to output X and Y and see what they look like. So be thinking about what they might, what you might get for X and Y. So I'm going to uncomment these. And I'm going to say X, output X, and then output Y and not the column. Okay, so I'm going to put, again, we had X, which was 0. We set it equal to Y, which is all ones, and then X multiplied times 10. So what should X be? You might think X is 10 and Y are all ones. So now if I run it, display, hey, wait a minute. X and Y are the same. Y isn't one all ones and 1 is all tens. Well, the correct way to do this is to use the copy to. Because this X equals Y basically puts them both at the same reference location. So it's referring to the same, when you use this equal, this assignment, they're basically the same at the same location. What you need is a copy to. So what I'll do is I will copy Y to X and then multiply X, and you can see that we have now what we expected. So we run it, and now we've got X is 10, Y is 1, which is the way we might have expected. So it's important to keep that in mind. That assignment is basically puts 2 things at the same location as opposed to just copying over. So that's a general introduction to MathNet Linear Algebra. I encourage you to start taking some of the methods and filling them in here and seeing what the results are. If you have any question, it's a lot easier to actually run this and see what the results are right in front of you. So I hope this has been helpful. Take care and have a really good day.